Hello, students. Have you ever wondered why, when you fill a balloon with air, it grows bigger and bigger, but when you remove some air, it shrinks? Well, this is exactly what Avogadro's law explains to us. In 1811, Amedeo Avogadro proposed that, under the same conditions of temperature and pressure, equal volumes of gases contain the same number of molecules. So, it doesn't matter if the gas is hydrogen or oxygen, as long as we have the same volume and the same temperature, the number of molecules will be identical. Pretty cool, right? Just think about it, whether it's hydrogen, oxygen, or any other gas, it all behaves the same way when measured under these controlled conditions. This idea revolutionized how scientists understood gases and laid the foundation for our modern theories on gas behavior. Let's dive deeper. Imagine you have 1 liter of hydrogen gas. Now, let's say you also have 1 liter of oxygen gas, both kept at the same temperature and pressure. According to Avogadro's law, these two lighters, despite being different gases, actually contain the same number of molecules. That's right. It doesn't matter if you're looking at a small, light hydrogen molecule or a larger, heavier oxygen molecule, the volume of gas is what determines the number of molecules. The law states that the volume of gas is directly proportional to the number of molecules it contains, given the temperature and pressure are kept constant. This helps us understand not only how gases behave but also how to calculate their amounts in a lab just by measuring volume. Now, let's bring Avogadro's law to life with a real world example. Picture this, you have 1 liter of hydrogen gas and 1 liter of nitrogen gas. When they react together, they form ammonia. But what does Avogadro's law tell us here? It tells us that before and after the reaction, the volumes of gases involved will contain the same number of molecules. In this reaction, one volume of nitrogen reacts with 3 volumes of hydrogen to form 2 volumes of ammonia, and all these gases, whether it's nitrogen, hydrogen, or ammonia, are under the same conditions of temperature and pressure. So, when you calculate volumes in reactions, you're always considering the number of molecules involved, and Avogadro's law ensures everything stays balanced. Let's take this a step further with a calculation. Suppose you have 1 liter of hydrogen and 1 liter of nitrogen, just like our previous example. The question now is, how much ammonia will you get from this reaction? Here's where Avogadro's law shines. Since 1 liter of nitrogen reacts with 3 liters of hydrogen to form ammonia, we can directly apply this volume relationship. Using Avogadro's law, you can calculate that 1 liter of hydrogen will react with nitrogen to form exactly 2 liters of ammonia. It's all about understanding that the volume ratio of the reacting gases stays consistent as long as the temperature and pressure are the same. This is why Avogadro's law is so important when we perform chemical reactions in the lab. It helps us predict the amount of product we'll get based on the gases we start with. Avogadro's law isn't just some theory we talk about in class, it has huge applications in the real world. For example, in the industrial production of ammonia, a gas reaction involving nitrogen and hydrogen, Avogadro's law helps chemists calculate exactly how much gas they need to react in order to produce a specific amount of ammonia. And it's not just for industrial reactions, it also plays a role in everything from calculating gas volumes in the lab to understanding how gases behave in the atmosphere. Whether you're filling a balloon or studying the air you breathe, Avogadro's law is at play every single day. It's a cornerstone in understanding not just chemistry, but the world around us. So, to wrap up, Avogadro's law is a fundamental principle that helps us understand the relationship between the volume of a gas and the number of molecules it contains, provided temperature and pressure remain constant. It's a law that makes life easier in the lab and in industries. helping us predict the outcomes of chemical reactions. Remember, equal volumes of gases contain the same number of molecules under identical conditions, a simple yet powerful insight that connects all gases, no matter the type. Chemistry is not just about equations and theories, it's about how we can use these principles to explain and predict the world around us. And that's the beauty of Avogadro's law. I hope this session helped you see how chemistry is more than equations, it's the invisible force behind cooking, cleaning, fueling, and even healing. Catch you in the next class with more fascinating reactions and real world connections.